Alright, so how does our life get how do we provide ourselves with more opportunities for growth here? Not harder, provide ourselves with opportunities for growth when it comes to an asymmetric diene. So what do I mean by asymmetry? Previous videos we had this one that it was the 2,4-hexadiene. Doesn't matter which way you look at it, you always get the same product. Now let's introduce a methyl group. And what I'm going to do is I'm going to throw the methyl group here on, put it on this carbon. So now we have asymmetry associated with the molecule. It doesn't look the same looking left to right as it does right to left. And what I'm going to do is I'm going to draw the structure flipped so you can kind of see that. So if I take this around the bond, rotate it 180 degrees, I end up getting this structure. So there are two ways to number this molecule. 1, 2, 3, 4, where our methyl group here is on the third carbon, or, oh, sorry, I put it in the wrong place. 1, 2, 3, 4. So here the methyl group is now on the second carbon. So what's going to happen now? Well, we still get 1, 2, 1, 4 addition, but we have to consider both possibilities. One where the first carbon is 2 carbons away from the methyl group, and one where it's adjacent. So basically we reverse this 1, 2, 3, 4. Again, I've just flipped it around. So we still get our 1, 2 addition. So our kinetic product, if we add HX, is HX, and our double bond stays here. Our thermodynamic looks like this. So we still have the 1, 2 and the 1, 4 addition. Again, a tip off here that you have a thermodynamic product is that you have a double bond between the H and the X here. So that's always the symptom of a thermodynamic addition. What about the other direction? Well, I still get the 1, 2 addition. So 1, 2. And I still have the 1, 4 addition. But in one situation, I end up with an X on that methyl group. On the other situation, I end with it apart from it. So if you have an asymmetric alkene, one where it doesn't look the same left to right as it does right to left, you're actually going to end up generating 4 products, 2 kinetic, 2 thermodynamic. So how does it look like Markovnikov or anti-Markovnikov? We'll talk about that in the next video. But the takeaway here is that if you do end up generating asymmetry, you've kind of complicated your life because you can order differently. You can do numbering 1, 2, 3, 4 left to right, or 1, 2, 3, 4 numbering right to left. And you're just going to consider the fact now that you got twice as many